So we have this function y equals 4 sine 2x squared, and we are supposed to find the volume of the solid that is generated by rotating the region bound by this function y equals 4 sine 2x squared and the x-axis. We're supposed to rotate it about the y-axis. And so here's our graph here of y equals 4 sine 2x squared, and then the x-axis. And so then that region would be this region here. And then if we draw ourselves a representative shell, if we're going to use the shell method because we're rotating about the y-axis, then we would have something that looks roughly like this shell here. Now what we have to realize is that if we break that shell vertically, so if we break it and then lay it out flat, what we would have would be a rectangular figure with area equal to length times width. So the surface area of this rectangular figure that we would wind up with would have an area of length times width. That length would be 2 pi x because it would be the circumference of this shell. Circumference is 2 pi r, so the radius would be whatever x value we get to from the y-axis over to some x value. R is just going to be that x value, so this circumference would be 2 pi x. So when we lay it out flat, the length would just be the circumference, or 2 pi x. The width would then just be the corresponding y value on this function, which is going to be 4 times the sine of 2x squared. And then the depth would be dx. It would be the width of our little representative figure that we're drawing here as we rotate and make this shell. And then to find that volume, we're going to then integrate from wherever we start here, which is going to be 0, over to where we're going to quit here, which is going to be the square root of pi over 2, because that's where this function meets the x-axis. So we're going to integrate then. We're going to integrate from 0 to the square root of pi over 2, the length times the width times the depth. And in order to do this, we're going to do a substitution. We're going to let u be 2x squared, this value here. Then the derivative of that would be 4x dx. And we've got our 4x here and our dx here. 2 times pi would just be a constant that we could pull out front. Now in order to do this substitution, then we will also need to substitute the limits of integration. So u of the square root of pi over 2 would then just be 2 times the square root of pi over 2 squared. And when we square the square root of pi over 2 squared, we're going to get pi over 2 times 2 will leave us with just pi. So that upper limit is going to be pi. When we plug 0 in, this lower limit of integration, when we plug that in to 2x squared, we're just going to get 0. So our new limits then are 0 to pi, and when we integrate sine of u du, we wind up with minus cosine u. So we're going to evaluate minus 2 pi cosine u from 0 to pi. And so we're going to wind up with minus 2 pi times cosine pi minus cosine 0. The cosine of pi is negative 1 minus the cosine of 0, which is 1. So we have minus 2 pi times minus 2, and we wind up with a total volume then of 4 pi.